Hello everybody, welcome to Dr.K.Liu Maths channel. This question is complex exponential, complex function or complex variable question from university students. And of course, before we go to the detail of this question, we have to clarify one thing, and that is that for any complex number, we can write into r cosine theta plus I sine theta. That is the polar form. And of course, by Euler formula, you can write that into the r times ei theta. That is the Euler formula. And if Ez equal to a plus bi, that is standard form. And now we go into detail of this one. For the part 1, calculate the real part, imaginary part, modulus, argument of this one. And of course, Ez is equal to x plus iy, e to the power Ez squared plus 3 conjugate. That I first calculate Ez squared equal to x plus iy. That is x squared minus y squared plus 2xyi. Therefore, this should be equal to x squared plus minus y squared plus 2xyi plus 3 conjugate. And separate that this into two parts. One part is this one, and the conjugate should be for the component of I should be becomes negative, then minus 2xyi. Then we can separate this into two parts. One part is e to the power x squared plus minus y squared plus 3 times e to the power negative 2xyi. Then for this part is actually equal to cosine negative 2xy plus I sine negative 2xy. That is for the second this part, second part. For the first part is actually you can see that it is the modulus. Therefore, if the question is real part should be equal to x squared minus e to the power x squared minus y squared plus 3 times cosine 2xy. And the imaginary part is equal to this negative side should be moved outside. Therefore, it is equal to negative. This is sign. And for in the modulus is equal to this one. That is equal to e to the power x squared minus y squared plus 3. And for the argument of course is equal to not 2xy but negative 2xy. But if argument equal to, but anyway, because there is can be a rotation about, and you can rotate 2 pi, then it actually the same value of this one. Therefore, if you mention the argument, you have 2 negative 2xy plus 2k pi. That is the argument. That means this one we can write in the branch form plus 2 pi I 2k pi. No, so not 2 pi, 2k pi I. They are same. Therefore, the argument should be equal to this one. If you mention the principal argument, you only take the that I think it take this one. You can take this one, but if you doesn't matter, it is not a principal argument, so you have to mention the argument should be plus 2k pi. K is any integer. Okay. Oh, so crazy. That's so crazy one. Okay, for the part B, calculate the modulus and argument of this complex complex number. Okay, and B, z equal to I factorize 1 over root 2, then 1 plus I plus 2I to theta. And okay, for part B, let me see that if z equal to this one, I copy this, and I have to change this into standard form. That is, it means R E I something. Then this is the modulus. This is the argument. In order to achieve this one, I first change this one. It's very technical. This part is very technical. That you can see that this EI pi over 4. That's 2 theta. In order to achieve this one, I create something that is EI pi over 4. And that can be separated into pi over 4 can be separated into two parts, pi over 8 plus pi over 8. And for the second part, E I theta can be changed to theta plus theta. And next step, this one I add theta minus theta. And this one I add pi over 8 minus pi over 8. So crazy. I can't believe this is work. And you can see that E let me see, and I, and that is pi over 8 plus theta minus theta minus pi over 8. That's the first part. Then second part, I create also this one. Then I pi over 8 plus theta. That's first part. Minus pi over 8 minus theta. And for these two, I can factorize in I e to the power pi I times pi over 8 plus theta. And for this one is equal to e to power negative I theta minus pi over 8 plus e to the power negative, I don't write negative first. Yeah, negative pi over 8 minus theta. Yes, it is so crazy. And this one, and I negative side multiply into the bracket pi over 8 minus theta. This is also minus negative. Oh, it is so crazy. Because e to the power I theta plus e to the power negative I theta over 2 should be equal to cosine theta. Crazy. Also very crazy. That is this part. This part is equal to 2 cosine pi over 8 minus theta. And this part, e to the power I pi over 8 plus theta. Therefore, I can use the branch the branch theory, pi over x plus 3 plus 2k pi I. Therefore, the argument, the modulus should be this part. This part is modulus. And the argument is equal to this one. Of course, you mentioned the principal argument. You can just write down this one. In my mind, I think if it is your assignment, you can write down like this one or both. This k is k is any real number in any integer. Yeah. Okay. Then for last part, for the final part. Okay, let's go to the part C. Part C. Okay, I open a blank sheet. Okay, write down the real part, imaginary part modulus argument of this function. If z is 1 minus I, I think it is a very easy question. And you can see f z equal to 1 minus I, e negative 1 plus 1 negative 1 plus I. Yeah. And first I write this into polar form. That is in polar form should be equal to root 2 e to the power this quadrant, negative fourth quadrant, negative pi over 4. Combine these two these things together, root 2 e to the power negative 1 this part, and multiply this one is I 1 minus pi over 4. Oh, easy. Real part is root 2 over e cosine 1 minus pi over 4. Imaginary part root 2 over e sine 1 minus root pi over 4. And the modulus is equal to root 2 e over 2 over e. The argument is equal to 1 minus pi over 4. Yeah, it is easy part. Okay, but anyway, I hope guys can enjoy this video. If you found Dr.K.Liu Maths channel is useful, please subscribe my channel. Bye bye.